Hi, and welcome to this video on differentiation, maths made easy. In this video we're going to look at something called the power rule. The power rule is used when we have a function and it appears in this form, x to the power n, and we use this rule, x to the n equals nx to the n minus 1. If the function isn't in this form, we try to make it into this form and then apply this rule. So let's have a look at some functions that we can differentiate. Before we start, let's see, like these first ones are in this form, x to the power n. However, these 1, 2, 3, 4, 5 are not. So what we need to do is we need to convert them, if we can, into this form, x to the power n. And for that we'll use the rules of indices. So 1 to the power x, 1 over x cubed, using the rules of indices, that's x to the minus 3. Or y equals 1 over x to the minus 4. That's the same as x to the 4. Y equals square root of x. That's the same as x to the half, to the power half, using the rules of indices. Cube root of x squared. That's the same as x to the 1/3 all squared, and that's the same as x to the 2/3. 1 over square root of x, that's the same as x to the minus 1/2. Okay, now we've done that, let's see if we can differentiate. Y equals 6x. Oh my god, how did that appear in there? Well, it gives us a chance to revise our common derivatives. That's the same as y equals a to the x, and that's differentiated dy by dx. That equals a to the x natural log of a. Okay, what I really want to do was y equals x to the 6. We want to differentiate that, applying this rule. So what we do is we bring the 6 down and minus 1 from the power, which is n, and that gives us dy over dx is 6x to the power 5. So the derivative of 6x, x to the power 6 rather, I'm confusing myself again, x to the power 6 is 6x to the power 5. Okay, let's carry on. X to the minus 5, we can check, is it in this form, x to a power? Yes it is. Dy by dx. Let's apply the power rule. Bring the minus 5 down. X minus 5 minus 1. and minus 5 minus 1 is minus 6, so that equals 5x to minus 6. Okay, and that's the answer. The derivative of x to the minus 5 is 5x to the minus 6. Okay, next, x to the power half. Is it in this form? Yes it is, so we can apply the rule, the power rule. dy dx is bring the half down, so that's half x, and then the power half minus 1, and a half minus 1 is minus a half, so that makes that a half x minus to the power minus a half, and that is the answer. Right, does this function look like this? No, it doesn't, so let's make it look like that. And how do we do that? Rules of indices, remember, over here we said 1 over x cubed was the same as x to the minus 3. So let's write that. X to the minus 3. Now we can apply the power rule. Bring minus 3 down. X minus 3 minus 1 minus 3x minus 4. And that is our answer. Okay, let's continue. Y equals 1 over x to the minus 4. Over here, from rules of indices, is equal to x to the power 4. Does this look like that? Yes, it does. So we can apply the power rule. Bring the 4 down. X 4 minus 1. So that becomes 4x, and 4 minus 1 is 3. And that is our answer. The derivative of 1 over x to the minus 4 is 4x cubed. Y equals square root of x. So rules of indices, square root of x is x to the power half. Does x to the power half look like this? X to the power n? Yes it does. So we can apply the power rule. Bring the half down. X to the half minus 1 equals a half x, and a half minus 1 is minus a half. And that is our answer. Okay, let's carry on. Does this look like this in a form that we can differentiate using the power rule? No, it doesn't. Let's use the rules of indices to make it look like that. So it's x to the 2/3. Now we can apply the power rule. Bring 2/3 down. X 2/3 minus 1 equals 2/3 x 2/3 minus 1. Do we know how to do that? If not, let's do some scratch work on the side. So that's 2/3 minus, and 1 is 3 over 3, and that becomes minus 1/3. And that is our answer. Okay, y equals 1 over root x. Is this in the form x to a power? No, it isn't. Can we make it look like that? Can we make it into that? Use our rules of indices. X to the minus half is the same as that. So x to the minus half. Now we can apply the power rule. Bring the minus half down. X minus half minus 1 equals half x minus half minus 1. Some scratch work if we don't know how to do that. So that's minus half minus 1. That's the same as minus half minus 2 over 2, which is minus 1 minus 2 minus 3 over 2. That's minus 3 over 2. And that is our answer. Okay, now let's try some other differentiations. And this time we're going to use a couple of different rules and bring them into play. So let's have a go at this. So let's have a look first to see if there are any rules that we need to apply. So this 2x to the 6, this is the constant rule, where the constant stays outside and we dy by dx x to the 6. So this becomes 2 times, bring the power down, 6 x to the 6 minus 1. So this is dy by dx equals 2 times 6 is 12, 12 x to the power 5. What about the next one? Y equals x cubed over square root of x. So let's see if we can make this into one term. So we have x cubed divided by x to the power half. So when we divide powers, we subtract them, so that becomes x to the 3 minus a half. Now we have 3 minus a half is 2.5, which is 5 over 2. So that becomes x to the power 5 over 2. Now, can we differentiate that using the power rule? Yes, we can. So this becomes x to the 5 over 2. Using the power rule, bring the 5 over 2 down. X, and then 5 over 2 minus 1. Can we do 5 over 2 minus 1 in our head? Well, if we can't, let's write it down. 5 over 2 minus 1, that equals 5 over 2 minus 2 over 2, which is 5 over 2 minus 2 over 2, so that becomes 3 over 2. Yep. So this is 5 over 2 x and the power 3 over 2. And that is our derivative. What about y equals sine of x? Now, from our common derivatives that we should know, sine x is cos x, so this simply becomes cos x. Now the next one, y equals tan x plus e to the x. This rule in differentiation, if we have a positive or a negative between two functions, we simply take the derivative of the first function and then add or minus the derivative of the second function. So the derivative of tan x is sec squared x. We should know that from our rules on differentiation. And the derivative of e to the x is e to the x. So this dy by dx becomes sec squared x plus, keeping the same sign, and then differentiate the second function, which remains e to the x. Similarly, with this differentiation, we have a minus sign. So we differentiate the first function and minus the differential of the second function. So let's have a look. I don't think we've done this in common derivatives yet, but it's one we need to do later. So the derivative of inverse sine x is 1 over square root of 1 minus x squared, and the derivative of log x is 1 over x. So this dy by dx becomes 1 over 1 minus x squared minus 1 over x. Now when we have a function in a denominator, as in these two, we cannot differentiate it. So what do? So we make it into a form that we can differentiate, something that we know from our list of common derivatives. So what is 1 over sine x? So 1 over sine x is cosec x, and cosec x we can differentiate. What is 1 over tan x? 1 over tan x is cotangent of x, and it is in our list of common derivatives and we can differentiate it. So let's do that. So this one equals cosec x, and dy by dx is minus cosecant, let's put that as CSC x cot x. 1 over tan x is the same as cot x, and we know that from our list of common derivatives, and dy by dx becomes cosec squared of x. and that's our derivative of 1 over tan x.